In this video we're going to talk about factorials, and we'll start out with the definition of a factorial. Factorials start with a positive integer, and here we're going to call that positive integer n. And the notation for a factorial is actually an exclamation point. So this says n factorial. The definition of this is to start with the number n and then multiply that by a number that's one less than n. And then we keep going. We'll multiply by a number that's one less than n minus 1. So if I take the number before it, n minus 1, and I subtract 1 from that, and then we'll multiply that by the previous number. So n minus 1 gets copied, and then we're going to subtract 1 from that number. So we start with that highest number that we see before the exclamation point, and then we keep subtracting 1 from that number, and we keep subtracting 1 until we get all the way down to the number 1. So let's simplify this a little bit. It starts to look like n times 1 less than n times 1 less than n minus 1. Now if I combine those like terms, I get n minus 2. And if I combine all the like terms here, I get n minus 3. And if I keep going, I might get something like n minus 4, n minus 5. But I keep going all the way until I get to multiplication by 1, and then we stop. Right. So let's look at an example of what we mean by this definition. 3 factorial. So 3 factorial would be to start with 3, and then subtract 1 from 3, so we'll multiply by 2, and then subtract 1 from 2, and we get to 1. Once we get to 1, then we stop. So what is 3 times 2 times 1? We get 6. Now we can also do this in a calculator, and I'm going to pull up Desmos, so desmos.com, and I'm going to click on Graphing Calculator. And I'm going to go to the keyboard, and I'm going to type in 3, and then if you go down here to ABC, you have an exclamation point, and it tells me that the answer is 6. So you can do these in Desmos as well. Alright, what is 5 factorial? So that would be 5 times 1 less than that, times 1 less than the 4, times 1 less than the 3, times 1 less than that, and once I get to 1, a positive 1, we stop. So what is 5 times 4 times 3 times 2 times 1? We get 120. Now you'll notice that because we're starting at that highest number that's n, and we start to go all the way down to 1, we start to get some repeats. So eventually, because I'm going all the way down to 1, I'm going to get to something like 3, 2, 1, and you'll see here 5 factorial, we also repeated that, we went down to 3, 2, 1. So there's going to be some repetition in the expansion of those factorials. Okay, now it becomes a little more interesting when we get to something like a fraction. 5 factorial divided by 3 factorial. So if I do the factorial expansion at the top, 5 factorial will be 5 times 4 times 3 times 2 times 1. Then at the bottom, 3 factorial is 3 times 2 times 1. Now typically when we look at fractions, we like to cancel common factors. So notice that when we did these factorial expansions that the last 3 digits match at the top and the bottom. So those are common factors. So the 1s would cancel, the 2s would cancel, the 3s would cancel, and I would end up with 5 times 4 at the top, and so really 20 over 1 or just 20. So because these factorial expansions start to match as we get further on down the line, what we do is we don't expand them all the way. So what I would do, it's kind of a little shortcut here, is I would stretch out either the top or the bottom using that factorial expansion until one of those factorials matched 1 at the top or the bottom. So instead of stretching out 3 factorial, I just expand the top factorial till I get to 3 factorial, which matches the bottom. So we know that that would be 3, 2, 1, 3, 2, 1, so we just cancel out the common factors of 3 factorial. So it gives us a little bit of a shortcut because we know what's coming after 3 factorial, and we don't have to write all of that out. We know that everything here is going to match everything here. So our strategy here is to stretch out the larger factorial. So in this case that was the 5. Just until it matches the smaller factorial. So it doesn't matter if it's at the top or the bottom. I'm going to choose the larger of the factorials. I'm going to stretch that out, but I'm going to stop stretching it out when in that expansion this factorial would match one that's smaller. And then I could just cancel those out. Alright, so it may not make such a big difference, that little strategy here, but what about this example? What about 108 factorial divided by 105 factorial? Now, we surely don't want to write 108 factorial, 108 times 107. We surely don't want to stretch out that factorial to get all 108 numbers. So we will just stretch out the larger of the factorials. So the larger one in this case is on top. We will stretch this one out. So subtract 1, and then we're going to stop there because we know what would happen after 105. We would just write 104, 103, 102, and we would keep going from there. So I'm just going to leave that as 105 factorial divided by, at the bottom I have 105 factorial. Since we know that the top 105 factorial would be the expansion of all the numbers lower than 105, and we know that's going to match that smaller factorial that's at the bottom, I'm just going to stop expanding and say, well, we know what comes after that. We know all those numbers are going to match everything that comes after that. So now all I have to do is multiply 108 times 107 times 106. Okay, and I get what is that? 1,224,936. Right. Now, if you tried to put 108 factorial in Desmos, it gives you a really huge number. And so that what that would mean is 1.3 times 10 to that power. That tells you that that number is so big that it can't be listed here on Desmos. And you would have to move that decimal place 174 times to the right to actually capture how large that number is. And that's what that 10 times 10 to the 174th power. That's what we call scientific notation. So trying to do that is much more difficult, even with a calculator, than doing that shortcut cancellation and then only multiplying those 3 leftover numbers together. Alright, and some of these you actually don't even have a calculator that will work for these. We just have n plus 2 factorial divided by n factorial. These are the ones that you would actually encounter when you get to calculus. A little more interesting, a little more abstract. So not just solid numbers, but some variables included. Now, what we want to do is use our strategy that we've been using. We want to stretch out the larger factorial until it matches a smaller factorial, either at the top or the bottom. So n plus 2 and n, which one of those numbers would be larger? We could say, well, it'd have to be n plus 2, because n plus 2 is going to be 2 more than n. So this is the larger. So we're going to stretch this out until it matches the smaller, which is the n. So I would start with n plus 2. So start with what's in front of the factorial, and we'll subtract 1 now from that. So if I subtract 1 from that, we would have n plus 1. So that's 1 less than the one before it. Okay, what's 1 less than that? Well, n plus 1 minus 1 just gives me n. and I'm going to leave that as n factorial. And I'm stopping there, remember, because I want to stop as soon as one of those factorials matches the smaller factorial at the bottom. And you really don't need the parentheses around the n factorial, so let's just get rid of them. Not necessary. There we go. So now n factorial at the top matches all the factors of n factorial at the bottom, and our final answer is just n plus 2 times n plus 1. So we choose the larger of the two on the top or the bottom of the fraction, expand it until it matches the one that's smaller, and then we cancel all those common factors. Alright, now this example here, I have n minus 1, and then I have n plus 1. So which one of those is larger? So it looks like it would make sense that n plus 1, so taking n and adding 1 to it, would be larger than taking n and subtracting 1 from it. So I'm going to start at the bottom, and I'm going to write n plus 1, multiply that by 1 less than that. Okay, so if I subtract 1 from that, that gives me n. Okay, now remember, I want to get all the way until it matches n minus 1. So I'm going to go again. If I subtract 1 from n, I get n minus 1. And then I'm going to stop there and say continue on. So I'm going to put my factorial to say that n minus 1, I'm going to continue with that expansion if I wanted to. Alright, but I'm not going to expand anymore because I know it matches all the common factors at the top. So I'm just going to cancel those common factors, n minus 1 factorial and n minus 1 factorial at the top and the bottom. Now anytime you actually officially cancel everything out, you leave a 1 in its place. So it's actually 1 at the top of the fraction, kind of as a placeholder, and then n plus 1 at the bottom times n. Now you can write that any way you wished. Some might prefer to write that as n times n plus 1. That's fine. Or if you wanted to do the distribution at the bottom, you could do that as well. So n times n would be n squared, n times 1 would be n. So any of those three are perfectly fine solutions. Now we're going to look at something called combinations. You will see this notation in the binomial theorem notes, so I want to talk about it here because it is related to the idea of factorials. So combinations. We use a capital C sometimes to represent what we call combinations in that notation. So sometimes you'll see something that looks like this, n with a capital C and then an R. That's actually exactly the same thing as this. These are both considered combinations. We see these really big parentheses and you see two numbers stacked on top of each other. This is not a fraction, it's representing n. So those letters n are the same thing and those r's are the same thing. The formula for both of those notations is actually using the factorial notation that we talked about. And how you typically read this combination is n choose r. Alright, so let's talk about using the formula, then let's talk about putting in our calculator, and then we'll talk about what it means. Alright, so 6 choose 4. So that's one way that we can read that. So 6 choose 4. The number at the top is the n value, the number at the bottom is the r value. Alright, so 6 choose 4. When we do this combination, we're going to use this formula, and we're going to get out a number from the simplification of that formula. So the 6 is the n, right, and the 4 is the r. So I'm just going to use that formula. So that would be 6 factorial divided by r factorial, which for us is 4 factorial, times the larger number, so the 6 minus that smaller number 4, in parentheses, and that's important, and then the factorial. So we're going to simplify that. So that's 6 factorial at the top divided by 4 factorial times 6 minus 4 is 2, so that's 2 factorial. Okay, now we're going to do the same thing we did before. We're going to stretch out, we're going to look at the top or the bottom, and we're going to find the largest factorial, and we're going to stretch that out using that factorial expansion until it matches a factorial at the bottom. Okay, so at the top I'm going to do 6 times 5 times, and I'm going to stop at 4 factorial. Okay, because 4 factorial matches that 4 factorial at the bottom. Okay, so now I'm going to cancel the 4 factorial at the top with the 4 factorial at the bottom. So now at the top I have 6 times 5, which is 30, divided by 2 factorial. Let's just go ahead and stretch that out. That would be 2 times 1, which is just 2. So the final answer for this is 15. Now, in the next set of notes, in the binomial theorem notes, I'm not going to ask you to actually go through and do this calculation. I'm just going to ask you to pull up Desmos and put that in. So let's talk about how Desmos will do this calculation for you. Okay, so I want you to know where the calculation comes from and the idea behind it, but I'm not going to make you go through and do all of that work. So we talked about in some calculators you actually would write it as in first and then the C and then the R. So in this case it would look like 6, capital C, and then the 4, which is exactly the same thing as 15. It gives you the same answer. Desmos is going to ask you to put the C in first, and then it's going to ask you to put parentheses around the N, comma R. Okay, so this is how Desmos is going to ask us to enter in this combination notation. Alright, now when I do it in the next set of notes, I really like this notation. It's a little cleaner, but Desmos likes this notation. So if you're going to use Desmos, you'll have to change it up a little bit. Okay, so all calculators do it differently. So let's go to Desmos and type that in. Alright, so for Desmos, I'm going to go to Functions, and I'm going to go to Stats. So you'll see down here it says N, C, R, and so you'll notice they have the N first and the C and the R. That's pretty standard notation. But when you click on it, you'll notice that it does NCR, and then it's going to ask you to enter in something into the parentheses. So what they want is for you to type in the N value first, and then a comma, and then the R value second. So that gives you an answer of 15. Okay, so you're welcome to use Desmos. You don't have to go through and do all that calculation by hand, but you could if you wanted. Okay, let's look at the next one. This one is 10, choose 3. So that's how you would say it. The top number is the N value, the bottom number is the R value. Okay, so if I use that formula that we have up here, it's 10 factorial divided by 3 factorial times 10 minus 3 in parentheses factorial. So 10 minus 3 factorial, that gives me 7. I don't really need the parentheses once I do that subtraction. So that's times 7 factorial. And I'm going to simplify this by hand, and you're welcome to do it any way that you wish. We have our strategy to choose, look at the top or the bottom and choose the larger of the factorials, which is 10, and stretch that out until it matches one of the smaller factorials at the bottom. So I'm going to go all the way to 7 factorial. So I have 3 factorial times 7 factorial, and I'm going to cancel those out. So at the top I have actually 720, 10 times 9 times 8, 720, times 3 factorial, which is 3 times 2 times 1, that gives me 6. 720 divided by 6, and that gives me 120. Alright, so once again, you can pull up Desmos. Okay, we did 10, choose 3. And that's our N value and the R value. And remember, Desmos is going to ask you basically to enter in to the parentheses the 10 first, comma the 3 second, so the N and then the R. And it's going to give us exactly the same answer of 120. Okay, so let's do that. Alright, so we'll pull up the keyboard. I'll go to Functions, we'll go to Stats, NCR, type in 10, comma, 3, and 120. Now the last thing that I want to do here is talk about what do combinations mean. And so there's a little definition here that says that combinations are the number of combinations that can be made choosing R objects out of the set of N objects. Okay, so let's talk about what that means. It's kind of nice to know what this number means and what you're actually finding. Okay, so I'm going to start out with kind of an idea here of, let's say that I have 4 markers on the table. And those markers are different colors. So let's say I have a blue marker, a red marker, a green marker, and a black one. So they're all different colors. And so this represents the total number of markers that I have on the table. This is actually, in this calculation, this is actually the N value, so the total number of objects that you have. Okay. So let's say that I would like to choose 2 at a time. Now the number of these objects that I'm choosing at a time is actually the R value. So how many different ways can I choose 2 of those 4 markers, right? So let's just think of some ideas. I could choose a blue one and a red one at the same time. I could choose a blue one and a green one at the same time. I could choose a blue marker and a black marker at the same time. So those are 3 different combinations so far. What other ways can I do that? How about a red marker and a green marker? Or a red marker and a black marker? Or what can I do? Green and black? Okay, so I think that's all the different ways. So we have a total of 6 different ways to choose 2 out of 4 objects. Now you'll notice also that the order doesn't matter, so choosing a red marker and a blue marker doesn't really matter the order. So we have a total of 6 different ways. So when you're doing this notation, let's say 4, choose 2 at a time, the answer that we got was 6. So this is really telling us that if we have a total of 4 objects and we choose this many at a time, the answer that we get is the number of different ways that can happen. Or you can also think of it as a number of different combinations of accomplishing that task. Okay. So let's think about one other thing here. So if I have, let's say I use the notation 4 choose 1. So I have 4 markers and I want to choose 1 at a time. So just 1 at a time. That's what 4C1 would be. How many different ways or how many different combinations would that be? Well, if I can only choose 1 at a time, then I can choose a blue, or I can choose a red, or I can choose a green, or I can choose a black. So that would be 4 different ways. So it turns out, as we go through this in the next video, that if you have N choose 1, the answer will always be N. So if you're only choosing 1, the answer would always be N. Okay, so that's something we can kind of recognize and kind of tuck in the back of our hat. Of course, we can always use a calculator for these, but it's kind of nice to know why the answer is what it is. Okay. What if I do 4 choose 4? So you have 4 different markers and you just want to choose all 4 markers. Well, there's only one way to do that. You just get your hand and grab all 4 markers and then you got them. Doesn't matter the order, we're just going to grab all 4 at one time. Well, there's only one way that can be done. Okay, so it turns out that if you do N choose N, the answer will always be 1. Okay, that's something we're going to encounter. We're going to see that. Something else that would make sense, hopefully now, would be if you put into your calculator 4 choose 5. So you have a total of 4 objects, but you want to choose 5 at a time. How many ways can you do that? Well, hopefully now it would make sense. If you put that into your calculator, your answer would be 0. There's no way to choose more objects at a time than you actually have objects to choose from. So typically this number is always smaller or equal to the N value. Okay, if it's not, if this one is larger, then you get 0. Right, so hopefully this gives you an idea of why your answer is what it is when you put it in your calculator and kind of makes sense of those answers.